Division, joined by Nicole Rayl and Gina DiBraccio.
Good afternoon, everyone, and I'm so pleased to be here. I am the acting division director for Heliophysics for a little while longer, and it's been a great year. I am joined by Nicki Rayl, who is the Heliophysics Associate Director for Flight Projects and Programs, and Gina DiBraccio, who is the Deputy Director of the Heliophysics Science Division at NASA Goddard. And we are excited to talk to you about the Heliophysics Big Year. Do we have a clip?
Great. Thank you, Peg. So there's so many of us here today because Helio is a big cross-functional, multidisciplinary division, and so we got a lot of people to talk about the science. We are very excited about the Heliophysics Big Year. It's an incredible opportunity to take stock of the amazing impact that the sun has on our daily lives for citizen science or activities for the public to join us in science. Science itself, from the incredible observations we can make during eclipses, as well as just, the sun has a profound impact on the rhythms of our life, how we wake and sleep, our immune system, how we grow food, how we get air, our communications from start to finish. This is an incredible opportunity for us to think about that. And more than anything, this Helio Big Year, we're in it right now. It started in October. We had an annular eclipse that took place in October. We're looking forward to a full eclipse coming up in April of next year. And we're going to round out, the Heliophysics Big Year is so big it's actually longer than 12 months. We're going to round out the year with Parker Solar Probe making its closest approach yet to the sun. Yeah. So the sun does truly touch everything. And in our big year, we have themes that we're going to be working through from month to month. We started off with the annular eclipse, as I mentioned, and we're jumping into citizen science and a bunch of activities we have coming up on missions. Really, all these teaser events for the big event, the big full solar eclipse in April of next year, and Parker's one of my favorites because not only is it literally touching the sun inside the atmosphere of the sun, but it's an engineering marvel, and I think such a true testament to the junction of science and engineering for us to accomplish this incredible effort. So, the annular eclipse that just occurred, we were deployed everywhere. Big shout out to our comms team, first of all, who had sites across the country taking place. Thank you all. You guys were incredible. From live shots going on with media to the Albuquerque Balloon Festival, which I think there's about 80,000 people a day, up to 125,000 folks there in person to watch the big event. It was such an event. I wasn't there. These guys are going to tell you some more about it. But it was an incredible time for just camaraderie, bringing the community together. And I love when we have these eclipse events, it really unifies the public, the scientists, and the engineers around a common theme that impacts our daily lives. I would love to take an opportunity for you to chat with these ladies a little bit about what their experiences were like in Albuquerque. Starting with Peg. What was it like for you, Peg?
It was amazing. Who would expect that they would have a balloon fiesta at the same time as an eclipse? It's just amazing. It was such an uplifting experience. But it was really an opportunity. All in all, eclipses are an event that everyone shares. Everyone can experience for themselves a celestial event. And it's a time when it's a wonderful opportunity for all of us to share our science while people are paying attention, looking up, thinking about the effects of the sun on the earth, thinking about the planets and their motions. So it was a wonderful experience. At the same time we were doing the broadcasts and the events in Albuquerque, there were sounding rocket launches south of us from New Mexico. There were 3 sounding rockets launched, one before the eclipse 30 minutes, one during, and one 30 minutes after, to really observe the changes in the ionosphere that happen when the sun suddenly dims and then brightens up again, and the same experiment will be launched from Wallops during the April total solar eclipse. So got wonderful data from that. I have to say, I don't love public speaking, and so the broadcast was terrifying for me, but all in all, it was a wonderful, exhilarating experience. And Gina actually was the host of a program from Kerrville, New Mexico, so I want to let her tell you about that.
All right, yeah, so I had the opportunity to co-host from Kerrville, Texas, and let me just say that this was one of my favorite memories working at NASA by far. I mean, this is exactly why I love my job. Not only do I get to do the science, but I get to talk about the science, I get to interact with people regarding the science, and these pictures kind of show what this event was like, right? So it's not just about that 4 minutes of annularity in terms of the Heliophysics Big Year, but really emphasizing that the sun does unify us and bring us all together. And this event really proved to be true for me because I got to interact with all of these different people that you see and more. So for me, it was kind of going through that whole experience with the NASA 360 production team, which it was just amazing to see all of the work that they do behind the scenes to make it so that you at home can even view the eclipse, you know, if you're not able to get out and see it. My co-host, Tahira Allen, amazing, you know, just to be able to kind of work with her and talk about our experience of the eclipse. You can see in the upper left corner there, my family got to join with me. So 2 of my 3 sons were there. And just to hear my 3-year-old and my 5-year-old talk about looking up at the sky and seeing that ring of fire, you know, that was kind of a proud mom moment for me that they could experience the sun as well. So that was really great. I mean, the crowd in Kerrville, they were set up right next to our broadcast stage, and they were just so happy and enthusiastic that when we had the 60-second countdown before full annularity hit, they were yelling so loud that Tahira and I couldn't even hear ourselves think. So just kind of like how excited the whole town of Kerrville was, and not only about the eclipse, but to have NASA there for the eclipse too. The NASA booth was just, you know, long lines going forever, and everyone was so excited. And so this was kind of just that precursor for the total solar eclipse that we have coming up, that the town of Kerrville will participate in again. So Nicki, I know you weren't there, but just describe your eclipse experience for us.
I was not there. I was in a news studio for a lot of the day, but the coolest thing about that was I got to experience annularity as it was moving across the country, talking to reporters and public, so that was awesome. The actual annularity, I was in my cul-de-sac in Arlington, Virginia with my boys, with our glasses on and all the neighbor kids looking up at the clouds. And it was a great rainy, cloudy day. We could see nothing, but it was a cool opportunity. We had kids from all over in the neighborhood and some Girl Scouts and Boy Scouts joining in, and at least we got to talk about why we wear protection on our eyes and what pinhole filters are. So there was something. But so the eclipse, you know, not only are there cool, you know, events for community building, there's also some incredible science going on. Gina, talk to us about this science.
Yeah, sure. And so at NASA, we have all of these different experiments and projects lined up for the eclipses. Now, there were some, you heard about the sounding rockets that Peg was describing that was part of the annular eclipse. Those will be taking place for the total solar eclipse as well. And those 3 sounding rockets will launch before, during, and after totality. They'll be launching from Wallops Flight Facility this time around. Now, some other cool science that we'll be able to do is study this kind of hot upper atmosphere of the sun called the solar corona. And the total eclipse is particularly special to do this because we can do some experiments that we don't normally have the opportunity to do. One of those is actually flying NASA's WB-57 high altitude aircraft with experiments on board. And those experiments are going to image in the near and mid infrared, but also visible light, so that we can really understand the composition of the solar corona, how it's heated to such extreme temperatures, but also kind of monitor the dust population around the sun too, which has ties to planetary formation and evolution, for instance. We have a bunch of citizen science efforts that are going on. We have ham radio operators who are performing experiments where they're sending their radio signals because the Earth's upper atmosphere and ionosphere is directly impacted during the eclipse too. So we can see how those radio signals and their characteristics change during the eclipse. And we have some other really fun experiments going on with radio telescopes where they're actually looking at the active regions on the sun, and as the moon moves across the sun, it's going to occult some of those active regions so that you're almost turning them on and off. You can see where the radio emissions are coming from those different active regions. And so that's kind of just a taste for you of some of the experiments that NASA has planned for the upcoming total solar eclipse.
And in the midst of this incredible Helio Big Year, we also recently launched a mission called AGU, Atmospheric Waves Experiment, to the International Space Station. It went up in November. It's recently been commissioning. We can't wait for our first light images. There's a little bit of roll of the video. Side note, I was watching the launch from home in bed with my kids, eating popcorn right before bedtime. So it was I didn't get to travel, but it was a great consolation prize. But this mission is going to help us understand how energy propagates through atmospheric waves, how the energy of the sun interacts with the atmosphere and ionosphere, and we can better understand how the sun is influencing not only space weather, but how it's also driving energy in our system. Thanks. So this is our family photo in heliophysics. I'm thrilled to be up here with some of my favorite colleagues, and this is our extended family here, from Parker Solar Probe, literally in the atmosphere of the sun, looking at the origin of solar wind, reaching out to a ton of our satellites that are in our spacecraft that are strategically placed around Earth, going all the way out to Voyager in the far reaches. And every spacecraft you're looking at here is strategically placed from a unique vantage point to really look at the sun universe connection as a system. And we do that with our Heliophysics Observatory and all the data running in from our missions that are in development and those in operations, so that we can holistically better understand how this system functions. I'm curious, Peg and Gina, what missions? We got a bunch of missions coming up. I feel like it should be the Helio Big 2.5 years because we have so many launches happening. But we have a few near-term launches. What are you excited about in some of our very near-term launches?
So I'm looking forward to the IMAP launch. It's the Interstellar Mapping and Acceleration Probe. But this is a unique launch that is carrying 2 other spacecraft with it to the Lagrange 1 point, which is a stable position where it is always in the same place with respect to the sun and the Earth. So it's a wonderful vantage point to view the solar wind. It's a wonderful vantage point for space weather. And so because of that, the NOAA Space Weather Follow-On mission is also going to be launched along with IMAP, as is the Carruthers Geocorona Explorer. So 3 missions launching at one time early in 2025. So I'm really looking forward to that.
And Gina, how about you?
Okay, so I'm going to say that Escapade down over here, which will be going towards Mars, is one of the things that I'm looking forward to. Launching next year, Escapade is 2 small sats that's heading to Mars to understand the transfer of energy and momentum from the sun into the Martian environment. And so the reason why I'm excited about Escapade is because the role that it will play in understanding space weather at Mars. So we talk a lot about space weather at Earth and the impacts that it has to our infrastructure, to GPS and communication, and also astronauts who are aboard the space station and soon to be on their way to the moon. But we have to think about this at Mars as well. And so we do have observations currently from the MAVEN mission, which is part of the planetary fleet that helps us to monitor the solar inputs at Mars, but also how Mars Mars really responds to those. And so Escapade is going to help us to unravel these mysteries a little bit more, but having two small sats means that we can actually distinguish between both the temporal and the spatial scales to really kind of get at what's driving the system. Now, this is important for robotic missions that we have coming up going to Mars, but also for humans. So not only do we want to understand the system and how to respond, but we want to prepare and create the tools so that astronauts have the ability to assess space weather that could be coming their way so that they know how to react and how we can protect our humans and our astronauts. So for science, but also for the future of exploration, I'm going to go with Escapade and space weather at Mars.
That's a good one. I love the intersection that we've heard from our BPS colleagues, our Earth science colleagues, and we'll hear from our planetary colleagues. So Heliophysics Big Year is an incredible event for us. Not only are we, for us all, or not only is there an amazing science that's coming down the pike from the missions and development, we're collecting incredible data on a daily basis from our fleet that's observing 24/7. And I hope that, it's a little bit of an opportunity for you to connect with your local communities on what your science is, because most sciences have some, driven interaction from what the sun's effect is on Earth, if it's atmosphere, if it's Earth, if it's, out into interstellar medium, but plant science, astronaut health and safety, and if you're someone like me that relies like a crazy person on your GPS to get anywhere in life, like here from the Moscone Center to my hotel to find a restaurant, space weather events have the potential to really impact some of our communications and infrastructure. So it's a really interesting holistic study of what's going on. In addition to this being the most incredible images, I'm a biologist by training, and when I look at images of the sun, it reminds me of a living thing. With these CMEs and flare events, it's so dynamic, it's so incredible. And when you think about, as we're looking forward to exploration and humans moving beyond and what the impact of that will be, I'm thrilled that we have the spacecraft fleet that we do. And with that, we really hope that you will participate with us on this Helio Big Year. Great old QR code if there's ways, you can look at ways to engage on citizen science activities that are going on, what the map of totality looks like, events that are going on in your community. Please join with us as we experience these incredible phenomena from the sun and also work to develop our spacecraft that are coming up. I know I'm going to be pretty busy the next year and a half trying to get all those big guys off the ground. And with that, I'm going to turn it over to Peg. Peg, do we have made some interesting news to share with this group?
Yes, we do. So many of you may have heard we have recently announced the selection of the next division director for the Heliophysics division, Joe Westlake. Dr. Joe Westlake from the Applied Physics Lab is here to soak up the attention. And so Joe is a space physicist from Applied Physics Lab. He has been involved from the planetary side in the space physics that we study in heliophysics, and has been involved in both heliophysics and planetary science missions for a number of years, has experience both as a researcher and a developer of flight hardware. And I'm going to just delighted to have Joe coming on board and want to let him say hello, and then he'll be at the heliophysics table after this, so if anyone would like to come and get acquainted, he's getting very acquainted this week. So
thank you, Peg. Yeah. Thank you all so much. I'm really, really excited to work with this group of wonderful people. Heliophysics is just an amazing, amazing science discipline, and I'm really, really excited to work with these folks and work with the team at NASA and work with everybody in this big, broad, vibrant community that we have. As Peg noted, I'll be hanging out over here, listening, talking, chatting with folks. Feel free to swing by and say hi. And go Heliophysics.
thank you, Joe. And thank you, Nicki and Gina, and go Helio Big Year.